Hi guys, and welcome to the Stall Secondary College Subject Selection Expo for 2021 subjects. My name is Mr. Oliver, and I'm here today to have a talk to you about Units 1 and 2 Physics. Units 1 and 2 Physics is available for Year 11 students and possibly, depending on your application, some Year 10s as well. So let's go through Units 1 and 2 Physics. So, physics questions. How can we calculate the speed of light with cheese? How can we measure the temperature of the sun? How can we slow down time? How can E equals mc squared help us to create free energy? All questions that we might be able to answer using physics. All right. They seem like silly questions, but throughout the course, we use our scientific inquiry to go through and answer questions like this. So what is physics? Physics is the study of the universe and how it behaves. It helps us to understand the world around us by exploring how things move and what they're made of. We look at things all the way from a microscopic level or subatomic level even, up to microscopic, up to our everyday lives, and then even out into the great expanse that is the universe. The areas of study in VCE, VCE is made up of 4 units, 1 unit per half year of Year 11 and 12, so that's 2 terms per unit. I think it's really important to understand where you would be going, so we need to talk about Unit 3 and 4 as well. So things we look at, what ideas explain the physical world? So things like thermodynamics, electric circuits, matter, radioactivity, we look at in Unit 1. Unit 2, what do experiments reveal about the physical world? We look at things like motion. We do a big experimental section, as well as we have a study option in Year 11 to pick a certain sub-branch of physics to look at, and you guys would get the choice on that one. Unit 3, we look again into motion, but then we look into fields to explain motion and electricity. So we look into gravitational fields, we look into electric fields, stuff like that. And then Unit 4, how do 2 contradictory models explain both light and matter? We look at light as a particle, we look at light as a wave, and we explore the connection between those 2 models. So Unit 1, we really go into depth with thermodynamics. So we look at heat and temperature, we look at climate science. We go into electrical circuits. So we spend a lot of time building circuits and creating circuits to use in class to help us explain how electricity is split up and used effectively. And then we go into matter. We look at the Big Bang, we look at quantum physics and nuclear physics. We look at radioactivity, and there are a few really cool experiments that we can do, including like froth on a drink, and we can pour them and measure the amount of bubbles over time. That was a great experiment that we did last year. Unit 2, so the second half of Year 11, we look at motion, all right, movements, forces, and energy. We analyze things like that picture of the skateboarder there. We look at things like ball sports, projectiles, air resistance, friction, stuff like that. Which is, we see every day, but we might not understand exactly how it works, and we look at stuff to do with ball sports. And we do a practical investigation. You guys get to individually design and complete your experiment. So you get the choice of that. You can do your own. Sometimes we work in groups. Sometimes we do whole class ones, but a lot of the time, you get quite a bit of choice with your physics study. Unit 3, we go on to look at gravity, magnetism, electrical forces. We look at the bigger picture of how forces help shape and manipulate our universe. We look at electrical energy, so the generation and transmission. We look at things like step-up transformers, things that are used around that you drive past every day that you wouldn't necessarily think to look at. And we do some more motion. So we look at circular motion, projectile motion, and relativity. So traveling away from Earth at the speed of light for 5 years, you come back and everyone else has aged 60 years and you've aged 20 years. Like we have a look at why that is a possibility, potentially in the future, but it's very uncertain as to what's going to happen in that field. So it's really interesting to discuss. And as you can see in the picture, theme parks, well, we actually, hopefully, fingers crossed, we can head down to Luna Park and have a look at some of the stuff there. And then Unit 4, which is the last half of Year 12, well, it's basically Term 3 of Year 12. We look at light, sound, and wave properties. We look at light as a particle, and we look at the particle-wave duality, right? The two competing ideals that light is a wave, but light is also a particle. We look at matter waves, and we look into a little bit more of the quantum mechanics. Finally, we finish off with a practical investigation. Again, you get to individually design and undertake this experiment. Last year, we built about a 2-meter high catapult. It wasn't very good because we were rushed for time, but we did get to launch some like shot puts up on the back oval at school, which was really awesome. What do we get to do in class? We use maths to explain things in everyday life. We use reason and we discuss why things work the way that they do. We explore the history of discoveries and real-world applications of the concepts that we're studying. And we also investigate phenomena through practical experiments. A lot of the time, we'll do a practical experiment before we study the theory to help you formulate your own ideas and discuss your own ideas about that thing before we actually look into it. Where can it take you? All right. Engineering, science, health, IT, transport and defense, teacher, if you wanted to teach physics. I didn't think I would, but here I am. And for many subjects in engineering and science, it's a prerequisite, and you will cover it. From my experience at university, I covered a lot of things that I did in Year 11 and 12 physics in university, and I was very grateful for the opportunity to have done that. What jobs could you do? Well, here is isn't an exhaustive list. This is just what I could come up with off the top of my head. So things like aeronautical engineering, sound, audio engineering and acoustics, computing, climatologist, meteorologist, mathematician, oceanographer, pharmacist, you name it. There's probably some physics involved with it, and it's always good to have that sort of underlying understanding of what's going on when you're trying to do a job. Why should you do physics? If you want to understand the way the world works, if you want to be provided with a really quite a wide range of opportunities, and it's fun and it's challenging and it's rewarding. I'm not going to sit here and say that physics is a walk in the park, because it's not. Some of it is quite tricky to get your head around, but once you do, then you start to really appreciate and understand the world around you, and it is just I think it's a really, really enjoyable subject. And who can do it? You can do it. There's really no prerequisites. We do recommend that you study math methods concurrently with it. So try not to, if you're going to pick physics, try and make sure that you're doing math methods and not further maths or general maths. It's quite a big leap mathematically from further to physics, whereas math methods is very complementary to the physics study design. And if you're doing math methods, you've got quite a good understanding of maths, which will ultimately help you with physics and help you in that manner. Guys, thank you for sitting around and listening to me bog on for 10 minutes about physics. If you would like any more information, please feel free to contact me and ask me about it. More than happy, very passionate about physics and maths and doing them as subjects. And I think we can do some really, really cool things next year in physics. Have a lovely rest of the day. See ya.